Find on your reaction map where alcohols are oxidized to aldehydes or ketone, and with all but the mildest oxidants, an aldehyde will turn into a carboxylic acid. So it'll look like something like this primary alcohol can become an aldehyde, and then a carboxylic acid. Whereas for a ketone, we would have a secondary alcohol that becomes a ketone. So now let's look at some examples. We can take an example from time before where we had 2-methylbutanol. There's our methyl group, there's our alcohol, and the rest of our 4 carbons. And can go to an aldehyde, but it's not going to stop there with most oxidizing agents. It's going to continue on to form this carboxylic acid. We're going to go backwards now. If we have this molecule here, what alcohol would form this? If we look up here at our aldehyde, the carbons are the same for the aldehyde and the alcohol. The carbons are the same for the carboxylic acid and the alcohol. And if we finish our ketone, we've got R1, R2, and this carbon in the middle. The carbons are the same for all of them. So we're going to draw the carbons the same. Now what's different? Here's the carbonyl group. Here's the alcohol. That will be the alcohol that can form this ketone upon oxidation. All right, now let's do a carboxylic acid. We want to form this carboxylic acid from oxidizing an alcohol. Remember, the carbons are going to be the same, so we copy the carbons down. We just have fewer bonds to O. Here we've got 3 bonds to O. We're going to replace those with 1 bond to OH and 2 bonds to hydrogen. So we'll be left with just this OH.